My dear students, today we are going to learn in the chapter Combustion and Flame that what is fuel, structure of flame and zones of the candle, and we will also learn about calorific value of fuels. Today we are going to discuss the structure of a flame. So mainly there are three part or zone of candle flame, that is innermost zone, middle zone and outer zone. So the innermost zone of the unburnt wax vapors are black, cause the vapors are not burnt and therefore it is the least hot zone. Next, in the middle of the wax vapor start burning and the color of the flame is yellow, as oxygen available in this region is not sufficient for the wax vapor to burn completely, and therefore the temperature in this zone is moderate hot or not very hot. The wax vapor of the outer zone burns completely in the presence of sufficient oxygen from the air, and hence the color of the flame is blue and the temperature is very high. Let us perform an activity to show that the innermost zone of the flame consists of unburnt wax vapors. Take a candle and place it on a table. Now light it with the help of a matchstick. Bring a glass tube and introduce one end of the glass tube in the innermost zone of the flame. Now bring an ignite matchstick at the other end of the glass tube. What do you observe? You will observe a flame at the end. So we can say the innermost zone of the flame near the heated wick consists of unburnt vapors. These wax vapors enter the glass tube and come out from the other end, and introducing a lighted matchstick near the end of the glass tube, the wax vapors coming out of it catch fire, producing a flame. So we can say that the innermost zone of flame near the heated wick consists of unburnt vapors. Let's perform another activity to show that the luminous zone or the middle zone of the flame consists of unburnt carbon particles. Take a lighted candle and place it on the middle of the table. Introduce a glass slide in the middle of the luminous zone with the help of a pair of tongs. Hold the slides for about 10 seconds. Now remove the slide from the flame and then observe. A circular blackish ring is formed on the middle of the slide. So we can say that the luminous flame consists of unburnt carbon particles, the outermost zone. This activity will be performed to show that non-luminous zone is the hottest part of the flame. Similarly, place the lighted candle on the table. Now hold a thin, long copper wire just inside the flame with a pair of tongs for about 30 seconds. Now observe carefully. The part of the copper wire just outside the flame is turning into red color. That means it is becoming hot. This is the non-luminous zone of the candle. So we can say that it has a high temperature and is the hottest part of the flame. So we can summarize it in this way. In the outer zone, complete combustion of fuel takes place and the color of the flame is blue and is the hottest part of the flame. It is the non-luminous part of the flame. In the middle zone, partial combustion of fuel takes place and the color of the flame is yellow and is moderately hot part of the flame. It is the luminous part of the flame. And the inner zone, there are unburnt vapors of the fuel and the color is black and is least hot part. What do you mean by fuel? Any substance that is used to produce energy is called fuel. There are mainly three types of fuel. They are solid, liquid and gaseous. Solid fuels are wood, coal, charcoal. Liquid fuels are kerosene, petrol and diesel. And gaseous fuels are CNG, LPG, biogas, hydrogen, etc. The main characteristics of a good fuel are: it must be readily available, it must be cheap, it must be easy to store and to transport, it should burn at a moderate rate, produces a large amount of heat, and it doesn't leave behind any undesirable substances, does not cause pollution. We use different kind of fuel to perform different kind of activities. Do you know why? Because all the fuels, they do not burn at the same efficient rate, or we can say all fuels do not burn efficiently. Efficiency is determined by the calorific value. So what is the definition of calorific value? The calorific value of fuel is the amount of heat energy produced on complete combustion of 1 kg of a fuel. The calorific value of a fuel is expressed in kilojoule per kg. Alright, so calorific values of some fuels in kilojoule per kgs are given in the table. The cow dung cake's calorific value is 6000 to 8000 kilojoule per kg. Now look at the calorific value of LPG. It is 55,000 kilojoule per kg. That is why using LPG is more efficient than using coal. We can also say that on complete combustion of 1 kg of LPG will produce 55,000 kilojoule of energy. And hydrogen has the highest calorific value among all fuels. As we all know that burning of fuels lead to harmful products. Fuels like wood, coal, petroleum release unburned carbon particles. These fine particles are dangerous pollutants, causing respiratory diseases such as asthma. Incomplete combustion of these fuels gives carbon monoxide gas. It is a very poisonous gas. It is dangerous to burn coal in a closed room. The carbon monoxide gas produced can kill persons in their sleep. Burning of fuels lead to harmful products. Combustion of most fuels release carbon dioxide in the environment. Increased concentration of carbon dioxide in the air is believed to cause the global warming, and we all are familiar with the term of global warming. Burning of coal and diesel releases sulfur dioxide gas. It is an extremely suffocating and corrosive gas. Moreover, petrol engines give off gaseous oxides of nitrogen. So, gaseous oxide of nitrogen, gaseous oxide of sulfur, that is the sulfur dioxide, both are dangerous. Oxides of sulfur and nitrogen dissolve in the rainwater and forms acids. These acids lead to the formation of acid rain. It is very harmful for crops, buildings, and for soil. What is deforestation and global warming? For centuries, wood was used as domestic and industrial fuel, but now it has been replaced by coal and other fuels like LPG. In many rural parts of our country, people still use wood as a fuel because of its easy availability and, of course, the low cost. However, burning of wood gives a lot of smoke, which is very harmful for human beings. It causes respiratory problem. Also, trees provide us with useful substances which are lost when wood is used as fuel. Moreover, cutting of trees leads to deforestation, which is quite harmful to the environment. So we must stop using wood and we must try to incorporate fuels which has high calorific value. Global warming is the thread in recent days. Global warming is the rise in temperature of the atmosphere of the earth. This results, among other things, in the melting of polar glaciers, which leads to a rise in the seawater level, causing floods in the coastal areas. Low-lying coastal areas may even be permanently submerged underwater. Just imagine the consequences. The use of diesel and petrol as fuel in automobiles is being replaced by CNG, that is the compressed natural gas. Because CNG produces the harmful products in a very small amounts. So we can consider CNG as a cleaner fuel. This is all for today. So read this chapter very carefully. Thank you.